Hey, what's going on, guys? So yesterday you received an introduction to the LinkedList class, and now for this project, your job will be to finish implementing the LinkedList class. And you'll do that by implementing 9 more methods in addition to the 2 that you implemented yesterday, beginning with the insert first method, right? And the job of this method is simply to take a value and place it at the very front of the list. Next, you got the remove first method, whose job is simply to remove the value currently at the front from the list. Then you got the get first method, who merely returns a reference to the value to the link object at the front of the list. The size function, self-explanatory, simply returns the number of links currently in the list. The find method will search for a certain value in the list and return a reference to it if it is able to find it, otherwise it'll return null. Okay. The remove method searches for a value in the list, and if it finds it, removes it, or if it doesn't find it, simply does nothing. The contains method returns a boolean. It searches for a value, a specific value, and if it's able to find it, returns true, and false if it's not, if it cannot find it. Then you have the display list method, which simply prints out the value of each link inside the list. And then last but not least, the index of method, which searches for a specific value, and if it finds it, returns the position of that value. And by that, what I mean is if a value happens to be fourth in the list, index of will return the number 3 because 3 is the index of the fourth link. Right. So now what this video will now do is illustrate how each of these methods work, and then your job will be to then do your best to try and translate what you see in this video into Java. All right, starting with insert first. So, like I said, the job of insert first is simply to insert a new MyLink into the front of the list. And of course, this will increase the size by 1. It receives 1 value as a parameter, the value you want inserted. It returns nada, nothing, and is a public method. Alright, so here's how it works. Suppose I have a list with 3 values, okay? 145, 79, and 234. And of course, the head member points to 145 because 145 is the front of the list. Alright, and now I want to insert 58 at the front of this list. Well, the first thing I have to do is create a new link object with 58 stored inside of it. Right. The next thing I want to do is I now want 58's next pointer. I want it to point to the current head of the list because the current head will, when it's all said and done, will become the second link in the list. Right. Then the final step is to take the head pointer and make it point to this new link object, thus completing the function. Right. Next, we have remove first, whose job is to remove the MyLink at the front of the list, and which would, of course, decrease the size by 1. Or, of course, if the list is empty, it'll do nothing at all. This method receives no parameter, and it returns no object. And it is also a public method. Right? So, here's how it works. Suppose this is my list, these are my values, and I call remove first. Clearly, when it's all said and done, I want 79, who's currently second in my list, to become the new head of the list. So what my code will do is it'll take the head pointer and make it head pointer point to whom the 145 is currently pointing to. Right. Now that I've done that, there's nobody is left pointing to 145. So once my method completes, the garbage collector will eventually come and destroy the 145 MyLink object. Next, we have get first, which needs no illustration. It's pretty straightforward. It simply returns the head of the list. It takes no parameter. Obviously, it returns a MyLink object because it returns the first MyLink object, and it is a public method. Next is another method that needs no illustration. It's simply the size method, which returns the size of the list. Now, this next method is a little more interesting. All right, the find method receives a number as a parameter. This number is the value we want to search for. And then if find is able to find it, it'll return a reference to it. And if it cannot find it, it returns null. Right? So here's my list. Currently has these four values, and I want to search for the value 94 in this list. Right? So since I do not know where the number 94 is located in this list, or heck, I don't even know if 94 is located in this list at all. So what I'm going to do is I'm going to start at the very front of the list and iterate through this each link in the list one by one. So I'm going to declare a new MyLink reference, and I'm going to call it iterator, since that's going to be its job. Its job will be to iterate through each link in the list. Right? So the first thing I will do with this iterator is I'm going to ask it to point to the same link that the head is pointing to. Right? Then I'm going to look at its value. I'm going to see that 125 is not what we're looking for. So I'm then going to have the iterator point to whom the 125 is pointing to. I look at the value. 64 is not what we're looking for. So we then find out who is the 64 link pointing to. Then the iterator will go there. Voila, 94. Here's the value that we're looking for. So now that I found it, the only thing left to do now is simply return the iterator. Return a reference to the MyLink containing the value that I'm looking for. Right? Right. The next method is the remove method, whom, like the find method, remove will receive a number as a parameter. That number is a value we want to remove from the list. So what remove will do is it is going to also iterate through the list until it finds the value that we're looking for. Then once it finds it, it'll remove that value from the list. Right? So here's my list. It currently has these four values, and I want to remove the number 94 from the list. Right? Now, once again, I don't know where the 94 is located in this list, or if this list even has 94 at all to begin with. All right? So once again, I'm going to have to iterate through the list one by one. All right? So just like before, the first thing we'll do is have the iterator point to the head of the list, look at the value. 125 is not whom we're looking for, so we go to the next element in the list. 64 is not who we're looking for, so we go to the next element in the list. Voila, here's 94. This is the element we want removed. All right. So clearly, all right, when all is said and done, what we want the remove function to do is take the link that stores 64 and have its next pointer point to 48. Right? But here's the dilemma. Here's the riddle you're gonna have to solve with your code. Let's backtrack for a second. Let's rewind. Right? Suppose you're the iterator, and you're currently pointing to the link that stores 94, and you know that you need the link before it, 64, to point to a new object. But how do we do that? How do we tell the link before the 94 to do anything when 94, that link doesn't know who's in front of it? A link only knows who comes after it. All right, 94 can communicate with the 48, but 94 cannot communicate with the 64. Right? So how do we communicate with the 64 to tell it, hey, you're pointing to a new link object, you need to point to 48. Right? That's the riddle you're going to have to solve when you're coding this. All right. Now these last three functions we won't illustrate because they are the way they work is very similar to how find and remove work. They all involve iterating through the list one by one. So since we've already seen that twice, we're not going to go through that again. I'm just going to explain in depth what these methods do. The first one being the contains method. All right. Now what contains does is it also receives a number as a parameter, and then it will then search for that value. If it finds it, it'll return true, indicating that this value is in the list. If we're unable to find it, it'll return false, indicating that this value was not in the list. Right? So clearly, the return type for this method will be a Boolean object. And next, you have the index of method, okay, who returns the position of the first occurrence of a specific value. All right. So, for example, suppose the value that I'm looking for just so happens to be at the front of the list. Then the number that should be returned is 0, because 0 is always the index of the first element in a container. Just like with vectors, just like with array lists. All right. Likewise, if the value that I'm searching for happens to be the 8th element, the 8th value in the list, then index of will return the number 7, because that is what would be the index of that value. Right? And last but not least, display list. All right? Display list will iterate through the entire list, printing out each value as it goes along. And it'll print it out in that format. The index of each value will be printed out, will be surrounded by brackets, followed by a colon, and then the value belonging to that link. Display list receives no parameter and returns no value.